Morning, guys. So we're going to continue our soil compactions, okay? So last week we already learned what is soil compactions. So today we're going to learn on the main purpose of soil compactions, okay? The main idea is that compaction is the application of mechanical energy to a soil mass to rearrange soil particle and reduce void ratio. As you can see that the compactions is an application of mechanical energy to a soil mass. Why you do this? This is in order to rearrange the particles and reduce void ratio. And this is to ensure the stability and effectiveness of the facility after the constructions. Okay, so the purpose of compaction before construction takes place is that you want to reduce subsequent settlement under working loads, okay? To ensure that there is no physical deteriorations. You want to increase shear strength of the soil. Compaction reduces the void ratio, making it more difficult for water to flow through the soil. And it is important if the soil is used to retain water, like earth dams or even for embankment. Then can prevent the buildup of a large water pressure that causes soil to liquefy during earthquake. Okay, so come to the basic concept of compactions. It is to assess the degree of compaction. It is important to use dry unit weight because we are interested in the weight of solid soil particles in a given volume, not the amount of solid air and water in a given volume, which is the unit weight. From the phase relationships, as we can see in here in dry unit weight, it's actually we have the specific gravity, the unit weight of water, 1 plus the void ratio. Okay, so if you rearrange back this formula, then you can see that, so this is the void ratio. Because for the specific gravity and for unit weight of water is constant, so as you can see that the dry unit weight is actually the one that governs the void ratio. The purpose of compaction is that we want to arrange the soil particles. So rearrange the soil particles means we want to make sure that the soil particles be able to find its perfect path so that it can create a good interlocking. It's good. Create a good interlocking, then it is actually well compacted. And while doing that, you are actually reducing the void ratio of the soil. That is the main idea of the soil compactions. Okay, moving on. There are 3 main factors affecting compactions. You have water content of the soil, type of the soil being compacted, and amount of compactive energy that you use for compacting the soil. So this factor that affecting the soil compaction is the one that we use in the main principle of compaction tests. As I show you in here, this is the apparatus for laboratory of compaction tests. So in this apparatus for compaction, you have a cylindrical soil mold. The mold, you have a standard size for this mold. Why? Because when every time people do, then people are actually doing the same kind of a test and it's repetitive. Then you have a column mold extensions. This column mold extension is that we want to ensure when we compact soil inside this cylindrical mold, okay, compact this soil inside here, you be able to compact until its top layer. So usually you're going to compact, say, 3 layers. Depends, we have 2 types of compaction tests. The first type is a standard compaction test. The second type is modified compaction test. So in the standard compaction test, basically we're going to make 3 layers. So when you do in 3 layers, we're going to compact each and every layers to ensure that the soil is well compacted. You're going to give a 25 blow for each layers. Okay, as I mentioned before, we have two types of compaction tests. Okay, the first one is a standard compaction test. The standard compaction test is compacted in 3 to 5 equal layers, and each layer you have 25 blows, and the compactive effort supply in this test is about 595 kilojoule per meter cube. Then this is the volume of compactions. You have the mass hammer and the drop hammer. So when you do it manually, you're going to raise this up to 1 feet, okay, 300 mm. Then after that, you're going to release over free fall. So when you release, then you actually give this energy to that particular soil for every layer. And you have another type, a modified compaction test. Compacted 5 layers compared to the standard compactions. Usually people do 3 layers. In modified compaction test, we use 5 layers. So within that compaction molds, we're going to mark 5 layers. You're going to take the height, then you mark, divide by 5, then you're going to mark 5 layers. Each layer is going to give 25 blows around in the circular motions as well as in the middle. So the mass of hammer is increased. As you can see, this is 4.9 kilogram. This is 2.5 kilogram. And the drop height is also increased for 1.5 feet, okay, for 450 mm. So with this, you can get actually almost 4 times of the energy supply to each layer of the soil. And as you can see in here, it's only 3 layers. But in modified compaction test is 5 layers. So when you have 5 layers, means that each and every layer is much more thinner. So when it's much more thinner, the energy that's provided for that particular layer is actually much higher. Why people do that? This is because the standard compaction test could not reproduce the density measure in the field. So, which is why the modified compaction test is being developed. Okay, so this is standard compaction and modified compaction test. Okay, so on our next class on Friday, I'm going to go into detail the factor that affecting compactions, as well as the purpose of you are doing this standard compaction or modified compaction test, its application in the constructions. Okay, any questions before we finish our class today? Any questions? So thank you very much. Thanks.